Hello everyone, welcome to math class. I see we have Johnny and Kim and Madison on. So we're just going to wait a minute for everyone else, and while we're waiting, you can watch the Rocket Man YouTube video, just like a first minute and a half or so. Just make sure you're on mute. And then also, while you're waiting, imagine that you got hired as a rocket ship engineer. So you want to either think or write down, or open a word processor and write down what would need to be included on a rocket ship blueprint. So we're going to learn about how this is connected to what we're talking about today in just a minute. Okay, more people coming. All right, so I think we're going to go ahead and get started because it looks like everybody is finally on and has joined us. So welcome everyone. So obviously today we are talking about rockets, but more importantly, we're going to be talking about something that goes along with rockets. So as you were brainstorming what needs to be included on a rocket ship blueprint, what are some ideas that you had? Kim says, the parts? Yes. So what parts need built? So you're going to know how many pieces go together, right? What else? Johnny? The size of the parts? Yep. What else? How about how many parts? Okay. Anything else? Emma? Yes, the time frame? Yeah, maybe how long engineers estimate it would take to build a part. So what else is really important about what else needs to be included on a blueprint would be measurements. They would need to know exactly how big something is, very specific measurements so that it could be built properly. And something that's included on that would be angle measurements. So that's what we're actually going to be talking about today, is angle measurements. So we're going to be finding angle measurements using a protractor and some knowledge that we learn about angle types. So here's our agenda for the day. We're going to be talking about the angle types in measurements, and we're going to review angle types first and review how to find angle measurements using a protractor, which should be really review for everybody. So you can find these notes in our Google Drive class document folder. And you can either print them and handwrite as we're going along, or I will also show you a method where you can do it in keeping the document in digital form, so you can do it on screen. We're going to also talk about how to find the measurements using a virtual protractor, and then we're going to talk about the new stuff, which is angle pairs, how to find angle measurement using this angle knowledge about angle pairs. Then we're going to do some practice together, and then we're going to talk about our independent practice where you'll actually be creating a rocket ship with a protractor and then finding angle measurements using the knowledge we learned about angle pairs. And then those will be due on Friday. So once you have the notes open, this is the first section. We talk about angle types, and this should really be a review, so we're going to go kind of fast through this. A right angle measures exactly 90 degrees, a straight angle measures exactly 180 degrees, an acute angle measures less than 90 degrees, and an obtuse angle measures greater than 90. Oh, yes. Sorry, Caleb? Is an 89-degree angle still technically an acute angle? The answer is yes, because it is technically still under 90, even though it's really close and probably would look like a 90-degree angle. It's still not, so it would still be acute. Okay, so real quick, I'm going to go to the document. Here's where the document files are. So if we open the document, you can actually open these right with Google Docs. So if you want to sketch each of these, there's a nice little drawing tool. So if we go to Insert, Drawing, and New, we can actually come up here and select a line and just kind of free draw the line Now the bad part is that unfortunately with drawings, there's something called a snap grid. And when you do electronic drawings, and they don't always line up. So your vertex may or may not line up. It's okay. This is just a quick rough drawing. So hit save and close, and that'll put it into the document where your cursor was. That's obviously not a cute. I made more like a 90-degree angle, but it's just an example. So we're going to go ahead and just, I'm going to take mine out so it doesn't automatically save it, and just close out of it. Okay. All right. So this is my acute, rough draw, obtuse, right, and straight. So yours should look something like that. Again, I'm going pretty quick because this should all be a review. Which angle types measure exactly 90 degrees? Kim, right angle. Good job. And the next one. Which angle types measure greater than 90 degrees? Johnny? Obtuse. Good job. So measuring drawing angles with the protractors, again, this should be very much review. So we're just going to go through it kind of quickly. Your protractor has two sets of numbers. And I have my handy dandy plastic one here so you can kind of see it. So there's the little numbers here, and then the bigger numbers here and the little numbers here. I will put this on screen so you can see it a little bit better than me just holding it up in front of me. Okay. If it's an obtuse, then you're going to use the larger number. If it is acute, you're going to use the bottom number. And then to measure the angle, you're going to line it up with the vertex right in the middle here. And then if wherever your angle hits through here, if it's acute, that's going to be the measurement. And if it's obtuse, so you're going to look at the lower number. If it's obtuse, then you're going to look at the higher number. All right. And this one goes in 5 increments. And it also has a ruler at the bottom. Sometimes they do, sometimes they don't. Most of the time they do. So, all right. So you can use your protractor to measure angles and draw angles on your note sheet if you're doing it by hand. This is what mine looks like up close, since it was kind of hard to see on the screen. Now the virtual angles, these are the different ones that are available. Today, we're going to be talking about just MB Ruler for Chrome, the extension, because this protractor works exclusively in Chrome, but it's a very nice little protractor. So some tips: don't mix and match tools and devices. Typically digital tools measure digital angles. Handheld protractors are for written or typed angles. Variations in images across devices can cause errors. So if you're trying to take your physical protractor and put it up to your screen, you're not going to get necessarily an accurate measurement, especially if the picture you're measuring is skewed. But even with a regular digital protractor, you wouldn't if the image was skewed. Excuse me. So with the digital protractor, it's just important to remember that if it's designed to measure digital angles, then you're going to use it for the just on the screen. If it's designed to measure physical angles, you're going to use the protractor that like the plastic one. Now there are some phone apps, and I said that right here at the bottom, that you can use that are meant to measure physical angles, but definitely want to make sure you check those, because sometimes they're not the greatest and they don't get great reviews. So definitely make sure that you are using one that is verified, that people have said, yes, it works well, because it actually uses your phone's camera to measure an angle on paper. So the one we're going to look at today is called MB/Ruler for Chrome. And it shows on the side of the browser window, and it can be used inside of Chrome. And it's great for use with Google Docs. So here's what it looks like. Here's the what it looks like on the side of the browser, and then once you go into the browser, here is what it looks like in the browser. So which scale on the protractor do we use for acute, the smaller of the two numbers? What about obtuse? Madison, the larger of the two numbers. Good job. So here's an acute and an obtuse. And I'm going to show you that. So if you're doing this digitally, okay, and you have this open in Google, here are angles here, and here is our MB ruler for Chrome. So what you can actually do with this, you can rotate it, you can pick it up and move it right in the center. And now, of course, mine's off a little bit because I just rotated it. But you need to make sure that line lines up as close as you can get to the vertex, because if it's a little off, your angle measurement will be off as well. So this one is really 40 degrees. I think it's just a little, make it a little smaller so we can kind of see, here we go, where it hits a little bit better. This line here is not supposed to cover the angle line. That's just part of the protractor. So as long as it's as close as you can make it, this one is 40 degrees. Like I said, it does take some persistency to get it exact. So that one looks like it's 40 degrees. And what about the obtuse one? Who has an idea what that is? Emma? Not 60 degrees, so we're going to be looking at the other number. It's 120. I know, I think my picture is covering the answer, but it's 120. Good job. So now we're going to draw each of these. This one's acute. With the protractor, it looks like that. I'm just going to show you instead of trying to do it on the screen here. When I'm a little box, you can't see it. So obtuse. Again, this one here, it's the measurement from here to here. So we're talking about this area from here to here, not from here to here. And right, you could look at it from either way because it's right at 90 degrees. Okay, so for the angle shown in the following photo, which measurement do I use? Jacob. 160 degrees? Yes, and how do we know that? Because it's obtuse, right? So we use the bigger number. Okay. Now we're going to get into some of the new, and we're going to talk about angle pairs. So how many is a pair? Madison. 2, right. So 2 is a pair. When you have 2 of anything, it's a pair. What are the different types of angles? Pairs of angles, excuse me. Complementary, supplementary, adjacent, and vertical. So those, I wasn't expecting that you would have the answer for, because this is new material. So complementary starts with a C. By adding a straight line to the C, we can turn it into a 9 and then add a 0 to make it 90. Or complementary also makes a corner. So you could think of it that way. So here's my 90. See, here's my C. Here's my line. Here's my 90. And to you guys, it looks opposite, but imagine it going the correct way that a 9 should be. So in order to find that, we're going to solve for x and y as we would just a basic algebraic equation. So 29 plus x equals 90. We're going to subtract 29 from both sides, and we're going to get that x would be equal to 61. So now for this next one, what would we do here? Madison. Good. We subtract 37 from both sides, and y would be equal to 53. Good job. So supplementary angles are next. So supplementary starts with s. By connecting the s, we can make it an 8 and add a 1 and a 0 after it to make it 180. So two angles that add together to exactly 180. And then supplementary angles also make a straight line. So like I said, you have an s, and then if you just connect the s, it makes it an 8, kind of like right here. If we just connected that, it would make it an 8, and if we added a 1 and a 0 to it, we know that it's 180. So same thing, same concept. We're solving for our variable here for that angle measurement. If we subtract 118 from both sides, we're left with 62 degrees. So I set up the equation for us already. Jacob, what would it be how would we solve for this? Right, we subtract 68, and then we're left with 112. Okay, good job. Adjacent angles. So this symbol right here is the symbol for angle. Don't get it confused with the less than symbol, because the less than symbol actually this line here goes straight down. This one goes straight across. So this is the symbol for angle. They are a little bit different. And arches sometimes represent how many, if the angle is the same measurement. I know my picture's coming it up here, but you can see these two lines here, and then there's one line here. So this shows that these angles, even though they look like one looks a little smaller, so they look similar, they're not the same measurement, and that's all that represents. So don't let that confuse you. So angles that are next to one another that share a side are adjacent. So name two angles adjacent to BAF. BAF. So I'll do the first one. How about CAB? Remember, when we do this, we can go in this order. And then F, A, and G. The next one, KAL. I have them on the screen, so this should be easy. Emma. Okay, it's CAK and LAM. Good job. And then Johnny. Give me two that are adjacent to JAM. Okay. All right. So JAG and LAM. Okay. Good job. Vertical angles. So the dash symbol here represents equal measurement. So I'm talking about this little symbol. So if you have one dash, these are equivalent. These two means that these two are equivalent. So angles that are across from each other, vertical angles have equal measurement. So A and B are vertical, and D and C, and they have equal measurement. So same concept here. We just need to recognize which ones are vertical, and then we solve for them as if they're supplementary angles. So T is vertical, so it's equal to 129. E and F are supplement, so 129 plus E equals 180. You subtract 129 from both sides, and then E is equal to 51, and F is equal to 51. So measurement of angle F is 93 here. So you can kind of look at it this way. And then what would the measurement of angle U be? Kim? 93 as well, because they are vertical. Good job. And then N is 2. So what are two angles called that add up to 180 degrees? So supplementary. Now I'm going to ask, given the image below, what is the measurement of angle T? Yes? Madison? It's 129, right? Because they're vertical and they're equal. Good job. So now we're going to do some practice. So if we know, don't try to use a protractor to measure these because they're not to scale, but if we know that TNB is 106 degrees, what is YNB? So we're going to do our subtraction, and we're at 74. So I'm going to let you guys try some here in just a minute. So the next one's complementary angles. So if we know that ZTG is 49, then what is BTZ? It would be, we'd subtract 49 from both sides, and it'd be 41. So for this one, if we know that angle ZKF is 96 degrees, EKU is its vertical angle, so that has to be 96 degrees as well. And then these two are supplement, so we would do the same thing. We would subtract our 96, and we would find that they're 84 and vertical, so then it's 84 as well, because they're vertical. All right, so for this one, this is an obtuse angle. We know that obtuse angles are bigger than 90. Which scale should we use? Madison. Not the top one. It would be the bottom, right? And the answer would be 120 degrees. Good job. So now I'm going to give you guys just a minute here to try some yourself. You should have been probably working through them while we were going over. And I'm going to call in some volunteers here. Okay, Johnny, what is the measurement of SEN? So we set up our equation, good job, and we're subtracting 148, right? And it's 32, good job. Emma, set up our equation, good job, and it is 90, not 180, and then we're subtracting 29 from 90, and we got 61, good job. So, for this next one, if the measurement of KTS is 81 degrees, what are the measurements of these angles and how do we know? So KTS is here, so our vertical is QTV. What would that be, Caleb? Right, it's 81 because it's a vertical angle. We don't even need to solve for it or try to measure it. Then, if that's 81 and that's 81, how do we solve for the other two? Kim? We would set it up like an equation, and I just put KTQ there just to represent that it's the missing value. And then you would subtract 81 from both sides, and you would end up with 99. And then, since KTQ is 99, then VTS also has to be 99 because they are vertical. Okay. Good job, guys. So this one should be fairly simple. So I'm already going to tell you that it's acute. We can tell by looking here and seeing how it goes down. So what's the measurement, Madison? Okay, we're not using the top number. It's not 130 because it's acute. So we're looking at it this way. So it's going to be 50 degrees. Okay, good job. So we're going to use the bottom number, and it's 50 degrees. Okay, so that kind of concludes our practice together. So what you're going to be working on, using a physical protractor, not a virtual one. The reason I'm doing it this way is because I feel like doing angle measurements with a physical protractor is almost a different skill than the virtual, even though they can be extrapolated and they're close to the same. I still feel like you need to know how to do it the physical way first, and then you can build on that and learn the virtual way, because there is that snap grid issue in the virtual drawing platform that you need to work on, and you don't have that issue when you're doing it on paper. So what you can do is use your protractor, your physical one, and then draw it. Now all angles and lines must be labeled and accurate. So also I want the angle types labeled that we talked about. That should be review, so it should be really easy. So right, straight, acute, and obtuse. And then you can be creative and color and add details, but I must be able to read all of your labels. If your details cover your labels, then that's a problem. And then you would either scan or photograph and then submit it via Google Docs. Then there's a second page that has a lot of finding these measurements using the angle pairs we just discussed. And I know that's new. Okay, so you're going to hand both of those in via Google Docs. And if you really like that digital creation, you can do it as a separate assignment for 5 bonus points. Just gives you extra practice measuring, and there's nothing wrong with extra practice because practice makes perfect. So here is what you're going to be looking at, and then also these measurements here, I'm not any of the line measurements, the straight line measurements. You can be creative with if you want to go above or make them shorter. I'm okay with that. What I'm checking for is these angle measurements. They need to be exact. Also keep in mind that this is symmetrical. So these measurements are the same as these ones down here. This is mine completed. And as you notice, even though I added detail and added my alien, I still labeled everything. So and you can still read all of my labels, okay? And then we're going to find the complement of these angles, the supplement, the vertical, use the vertical to find the measurements, and then you're going to use the diagram to find the adjacent angles. And then when you're done, you're going to be creating an exit slip on Flipgrid, a real quick video for this lesson. One thing you were excited to learn about, one thing you'd like to learn more about, and one thing you still have a question on. And that's due today. And everything else is due Friday. And I will be available after this for any questions to help you work through anything after this lesson is over. But what other questions do you have for me? Caleb. So Caleb asked, can I color my rocket ship with markers? The answer is yes, as long as I can read it still. And I can stay after to help you, Johnny. Yes. And okay, so and then the question was, how are adjacent angles related again? And the answer to that is they share a side. And that was from Kim. Does anybody else have any other questions? Okay, and like I said, I will be available to you after this. So more one-on-one, so we can work through any of those questions or any of those problems that you may have. Okay? All right, thank you. It was nice to see everybody. And I'll see you next class.